Hi, this video is on imaginary to polar coordinates. So we just want to convert from imaginary to polar coordinates. This is also, by the way, the same way if you want to convert from rectangular or Cartesian to polar coordinates. So let's go ahead and get started on this. So here we have an imaginary value, x plus iy, and we want to convert it into this form where you get the modulus or the absolute value and some angle. You could also see it written like this, where this cosine theta plus I sine theta represents the angle theta. So first off, the modulus, or the absolute value, is just equal to the square root of x plus the square of x plus the square of y, all square rooted. That's how you would get the absolute value. For theta, oh, my mouse is dead. Come on. So for theta, you would just do the inverse tangent of y over x, and that'll give you theta. But you want to be careful with theta, and I'll show you why in a second. So let's continue on. Scroll down. So let's try and do this problem right here. So let's say you want to convert 3 plus I4 into polar coordinates. So here I already said x is equal to 3 and y is equal to 4. So for this one, all you really need to do is, let's first solve for the absolute value, which is the absolute value would be equal to x squared plus y squared, all square rooted. And then we would just plug in the values for these. So x in this situation is 3, so you'd say 3 squared plus 4 squared, all square rooted. 3 squared would be 9, 4 squared would be 16, and this would all be square rooted. 9 plus 16 would be 25. This would be the square root of 25. Square root of 25 is just 5, so a would be equal to 5. Alright, so we got the first half done. Now let's go on and solve for theta. So theta, as we mentioned earlier, theta is going to be equal to the inverse tangent of y over x. And y in this situation was 4, right there. So we're going to say the inverse tangent of 4 over 3. And for that, I just recommend you just pop it into your calculator. And for this one, you're going to get an angle of 53.13 degrees. And then you could just rewrite. It. So we wanted to convert from 3 plus I4 into polar coordinates, and so we get 5 with an angle of 53.13 degrees. And that's how it would look after you convert it. So let's do another problem. Here we have, let's see, we have 7 minus I5, and we want to convert that again into polar coordinates. So again, we're going to solve for the modulus, or the absolute value. So you'd say 7 squared plus negative 5 squared, all square rooted. So 7 squared, that would be 49, plus negative 5 squared, that would be 25. Now this does not break down nicely, so you're actually going to get this. Well, this is going to be equal to the square root of 74, which that doesn't come down to a nice value. So I would recommend just either leaving it like that or popping it into your calculator. If you put that into your calculator, you're going to get 8.6, about 8.6. So let's come over here. Now let's solve for theta. Again, theta is equal to the inverse tangent of y over x. So this is going to be negative 5 over 7. If you put this into your calculator, you're going to get negative 35. I'm sorry, excuse me. Negative 35.54. If you want this positive, well, let's see where this is at on the coordinate system. So if we actually plotted this, let's see, we would go over 7 and down negative 5. So over 7, and let's say that's 7 right there, and let's say this is down negative 5 to that point. So it would be down to here. It would come out a magnitude of 8.6, and it would come down negative 35.54 degrees. I'm sorry, excuse me. So if you wanted this positive, all you really need to do is just add, or actually just subtract this from 360 degrees. So if you did that, theta would be equal to 324.46 degrees. So let's see. If you have 7 minus I5, that converts to the absolute value. Gosh, I'm getting sick, sorry. So 8.6. And you can either write the negative 35 or the positive 324. It doesn't really matter, so long as you know which one is which. I mean, they're both the same thing. It's just if you want it in negative or if you want it in positive. So, okay. So now let's do one more. Now let's say if you have a value that has both the x is negative and the y is negative. So in this situation, whoops. No, don't start yet. Okay, so again, we want to solve. If we want to convert this to polar coordinates, again, we're going to have to solve for the absolute value or the modulus, however you want to call it. We start off with negative 5, and we're going to square that. And we're going to add that to the other value, which is negative 4, and we're going to square that. So, excuse me. 5 squared, that's going to be 25. 4 squared, that's going to be 16. What? Didn't we do this? I thought we did this already. Did we already do this, or am I just imagining things? Oh no, I'm just imagining things. I'm sorry. It's early and I'm sleepy, so please forgive me. So 4 squared, that's going to be 16. Yeah, why does this seem so familiar to me? Am I just having a foggy brain day today? Yeah, I guess I am. Oh well, that's what I get for waking up early. So anyhow, let's see, 25 plus 16, that's 41. So now we got the value of alpha, or the modulus. Now we want to solve for theta, and theta is equal to tangent negative 1 of negative 4 over negative 5. Negative 4, negative 5. Again, just pop this into your calculator. And for that, you're gonna get 38.66 degrees. And for this one, you're gonna be like, what? Why is it 38.66? Because that doesn't really make sense. If you actually plotted this, you'd go with let's see, you'd go negative 5 on the x-axis, or on the real axis actually, because this is the real axis and this is the imaginary axis. Or you can call this the x and y axis. Yeah. So, x would be negative 5, which we came over here negative 5, and then the imaginary value, negative 4, going to go down negative 4, which, yeah, so that would come down to here. Not very neat, but oh well. So anyhow, that would come down to about there, and if you look at that, well, that angle is much more than 38.66 degrees. Turns out that this 38.66 degrees is just this angle right here. So That's because that's just the way the calculator works, so you have to be aware of that. So I recommend that you graph it as well as when you do it in your calculator, because it'll make a little more sense. So in order to get theta for this one, you actually have to add 180 degrees. So it's 38. Whoops. Golly, man, I'm so sleepy today. I'm sorry. So anyhow, let's erase that all. Scroll down just a little bit. So to get theta here, you're going to add 180 degrees to 38.66 degrees. That's going to give you a theta of 218 degrees 66, and that is what theta is. So in converting negative 5 minus I4 to polar coordinates, you're going to get the square root of 41 and an angle theta of 218.66 degrees. Okay, so sorry for the grogginess. I was a bit sleepy. I really hope these helped you and they made sense. And good luck in your classes.